the topics that we're studying this week is analysis of variance, or ANOVA. And before I get into some examples of how to solve some of the homework type problems, wanted to just create this video to talk about some of the key points with ANOVA. And one of the things that we've kind of seen up to this point is the t-test or the z-test, and these are the most basic kind of forms of statistical hypothesis testing. And there are numerous statistical tests, and this graphic here, this table here, just shows you a little bit of kind of some of the different ones that are out there. So in this course, we talk about t-test, which again is the most kind of basic statistical test that we have available to us. And this week we're going to get into one-way ANOVA. There is certainly a two-way ANOVA, and we may or may not get to that in this course. And then eventually we'll get into, over the next couple of weeks, we'll get into simple regression, which we'll actually touch on this week, and then we'll get into multiple regression as well. But as you can see, there are numerous other types of regression and ANOVA and MANOVA and COVA type tests. So we just really kind of touch on a few in this course. So back to our one-way ANOVA conversation. So again, this is kind of a step up from a t-test, and it's really a little bit more advanced test, but also a more efficient test than what a t-test would be for looking at more than 2 or 3 different means, population means. And also what's important about ANOVA is that it's going to really get us ready for learning how to read or interpret the regression analysis that we'll see with simple and multiple regression output within Excel or whatever type of statistical software that you might be using now or in the future. So for our purposes, we are going to typically be looking at 3 or 4 different population means, although technically ANOVA can be used for 2 or more means. And with one-way ANOVA, what we're looking at when we say one way is one factor. So a factor might be the amount of time that we spend per week playing video games, or it could be the customer satisfaction with a particular wireless company or with really any service, a number of different ways that we can use the test. But within that one factor, we have multiple levels, or what we refer to as categories. And for example, let's say our factor is the amount of time spent playing video games per week. An example of factors could be the various different age groups. So we might have, for example, 4 different age groups that we're studying and try to see if there's a difference between the means of those groups. So we have some familiar assumptions that we've seen up to this point before, and 4 key ones for ANOVA are, first, that the observations are independent of one another. Secondly, that the populations are normally distributed, and we can see a test later on in our textbook. We may not cover it in this class, but we have the ability to do a hypothesis test using the chi-square distribution, which is also kind of referred to as a goodness of fit test. But more advanced statistical courses would look at something like a KS test here, especially for regression type analysis. Again, there are other tests available to check for normal distribution, but the chi-square test can check for normal distribution, and it can also check for populations that are distributed with Poisson or discrete population distribution, so it can test a number of different distributions. We also have to assume or confirm that the populations have equal variances, and within our textbook there is the use of an F test or F distribution to confirm that we have equal variances, but we have more advanced applications as well that we can do. Again, we probably won't see these in this textbook or in this class, but Levine's test is one of them, and again, there are multiple others as well that are available. And finally, the observations that we have in our data set must consist of either ratio or interval data. So one of the cool things about ANOVA is that the hypothesis setup is pretty easy. It's always pretty much the same, in that the null for the null that the population means are equal, and for the alternate hypothesis, the population means are not equal, or we might say that at least one mean is not equal to the others. So for ANOVA, we utilize the F distribution, and this is kind of an example of what the F distribution looks like. You see it's a one-tailed distribution, it's right skewed, and we have the rejection area up here in the upper region, so it's always a one-tail upper region rejection area. And we have really two different types of degrees of freedom that we work with ANOVA. And it has to do with the various different variances that we're testing for within ANOVA, and two main ones are the sum of squares between and the sum of squares within. So with sum of squares between, the degree of freedom is referred to as d sub 1, and sum of squares within, the degrees of freedom is referred to as d sub 2. So what do these mean? Well, in short, you'll read certainly more about this in your textbook, but the sum of squares between is really defined as the variation that's between each sample mean and the overall mean. So what do I mean? What do I mean about sample mean or grand mean or overall mean? So what I'm referring to is, for the sample mean, if we use our video game example up here, if we have 4 different age groups, we're going to have sample mean, 4 different sample means, so one for each age group. So that would be what I'm referring to as the sample mean. When I'm referring to the grand mean or the overall mean, that is the average of all the observations. So if we have 4 different age groups, let's say we have 10 observations or data points within each age group, then that would be 40 overall observations. Now note with ANOVA that we do not have to have an equal number of observations within each group. We can have 8, 9, 10, 20 for our different groups. They don't, again, have to be equal. But we calculate the degrees of freedom with the sum of squares between, the variation between the sample means and the overall mean. We'd calculate the degrees of freedom as k minus 1, where the k is the number of levels or categories. So in this case, we had 4 different age groups in our example, so 4 minus 1 is 3. So that would be the degrees of freedom for the sum of squares between. For the sum of squares within, that is referring to the variation within each sample, so within each of the 4 different samples. And that degree of freedom calculation is n minus k, where n is the total number of observations across the category. So in our example with the video game playing, n would be 40. So 40 total observations, and k we set up here was 4 different samples or 4 different age groups. So 40 minus 4 is 36. And another way that we can refer to the degrees of freedom is with the total sum of squares. So SST, the sum of squares total is equal to the sum of squares between plus the sum of squares within. So by that calculation, we would say that the degree of freedom with sum of squares within, we said was 36. And for the sum of squares between, we said was 3. So 36 plus 3 is 39. So our degrees of freedom for this example would be 39. An easier way to calculate the sum of squares total would just be to say n minus 1. So degree of freedom for the sum of squares total is going to be n minus 1, which is, again, n was the total observations of 40, minus 1 is 39. So either way, we're going to get 39. And recall with degrees of freedom, we always have to have one degree that cannot vary, or one observation that cannot vary. All of the other observations can vary in data points, but in order to get our average and then eventually our variance or standard deviation, we have to have one set point to make it all average out. So the reason to kind of touch a little bit on this right now, and again, you'll see a lot more of this in the textbook, is kind of the question of why do we call this analysis of variance? If we're studying the difference between population means, and why isn't this called analysis of means? Well, again, this is just to show why it's called analysis of variance, is because there's different variances or variations that we're examining. These are just two. There are a couple of others that are examples of variance within the ANOVA analysis. So with all of these different things, the sum of squares between, well, you'll see mean sum of squares within, you'll see mean squares within. There are a ton of different scary looking formulas and long calculations that could make it easy to trip up and make a mistake. But it's important that you not try to work through these long formulas. It's important that you use the data analysis tool pack in Excel, and we will also at some points need to use Excel stat. So with the data analysis tool pack, you'll see me use that with the examples, with the homework examples. You'll see me also use Excel stat. And what this will do is calculate all these different variations for you automatically and make the homework much easier and much faster to complete. And there are some times, again, like I said, where you'll need to use Excel stat. You can do all the homework with just Excel stat, or really I find if you can use the data analysis tool pack first, that is a kind of a quicker, cleaner way to get the information that you need. Excel stat will be a little bit more involved just because it's more powerful. It can do more things. So one example for Excel stat is the Tukey-Kramer comparison test. So with ANOVA, that's going to determine that there is a difference between the different population means. So in our example with the video games, let's say the ANOVA results that there is a difference in the 4 different age groups. Okay, that's all it tells us. It's not going to tell us where the differences lie. Is that between groups 1 and 2, 2 and 3, 3 and 4, 1 and 4? Where does the difference lie? So the Tukey-Kramer comparison test compares each of those different pairs, those different combinations, and tests them to determine where the actual differences exist. So this is an example of where you would need to use Excel stat. So you'll see me use both within the homework examples. And again, I just stress that you use one or both of these different technology resources and not try to do everything by manual formula. Even if you are setting up in Excel, that's great. If you're setting up in Excel and using functions, that's certainly much better than trying to write this out on paper or using a handheld calculator. But again, you'll see in my homework example videos that you can solve these really quickly with either one of these tools.